Good morning, students. Today we'll study a topic CIDR, which stands for Classless Interdomain Routing. So in this topic, apart from the classful addresses what we have studied earlier, this topic discussed regarding the classless interdomain routing means a classless IP address. There will be no divisions of class as class A, class B, class C and class D. Here we will study altogether the classless addresses. So let us see this block diagram. Here we are still studying regarding the IPv4, which is of 32 bits. The size of the IPv4 is 32 bits. Here we divide them into 4 blocks, each block having 1 byte. At the last part we have /n here. So this n denotes the number of bits used for the network ID part. Means here we are using n bit as the number of bits for the network ID part. As we know earlier, your IP addresses will be divided into the network part and the host part. So this n denotes the number of bits in the network ID part here. So if you look at example 13.10.60.172/17, this 17 denotes the number of bits in this particular IP addresses. Then what will be the number of bits in the host ID? It is given by host ID equals to 32, that is the size of the IP address. Since it is an IPv4, the size is 32 bit minus 17, that is given in the given example /17, which denotes the number of bits in the network ID. That is 32 minus 17 equals to 15. So the total number of hosts that it can support is to the power 15. Actually it is to the power 15. Here I have written -2. -2 are for those two addresses. The first address is the network ID itself, and the second address is the broadcast address. So there are certain rules for forming this CIDR block. The first one, all the IP addresses should be contiguous. It means when we write the IP addresses or when we select the IP addresses should be continuous. Means there should not be any gap. Means when I select the IP, the last byte of the IP address is 32, the next should be 33, 34, 35 and so on. The second part, the block size should be to the power n form here. Then third part, the first IP addresses in the block that you selected should be evenly divisible by the size of the block. Let us see an example. So I have taken this whole block, and then if you check at the first part whether this satisfies the first point or not, since I have taken the block starting from 32, next it is 33, 34 and so on up to 63, means they are all continuous. There is no gap while selecting these IP addresses. So the first point is checked. So the second point, the block size should be to the power n. When I count this up to 63, it is having 32, means to the power 5, means the size is in the form of to the power n. The third point, so if this is the first IP addresses, so if you write in binary notation, it is in this format here. So what is the size of the block? It is to the power 5. If you want to see whether this divide this one evenly, then the last 5 bits should be 0. This one, the last 5 bits should be 0. If the last 5 bits are 0, then we call this one as the evenly divisible by the size of the block. So this is also satisfies here. Now let us see. So how many bits are there in the network part here? We have already made this one as the first IP addresses. So these 5 last bits are all 0. So this denotes the host ID, number of bits in the host ID. So the remaining 32 minus 5, that is 27, will denote the number of bits in the network ID part. So therefore, I have written this whole block I can write as 50.30.60.32/27. So this is nothing but the CIDR notations here. Let us see a question, whether we can solve the questions or not. The question asks, a classless address is given as 167.199.170.82/27. /27 is a CIDR notations here. The question says to find out the number of addresses in the network. How many addresses are there in the network? Then the second part, the first and the last address in the network. So we have to solve these two problems. Let us see the first one. The first one, the number of addresses in the network is given by 2 to the power 32 minus n. N is nothing but the value of this 27 in the CIDR notations. Why we have taken 32? This is because the given IP address is IP version 4 and the size of the IP version 4 is 32 bits. So to the power 32 minus n, that is to the power 32 minus 27 equal to the power 5 equal to 32 addresses here. There are 32 addresses. So you must remember that in these 32 addresses, there are two addresses. The first address is the network ID itself, and the second address is the broadcast addresses. But those two addresses we cannot use, but the question asks to find out only the number of addresses. So the total number of addresses is 32 addresses here. But if you are asked to find the usable addresses, then it should be to the power 5 minus 2. Okay. Second point, let us find out the first and the last address of the network. So the question, we have written this one, we converted them into the binary format. So in this question, we will see only the last part or the last 8 bits here. In this 8 bits, 27 means 27 number of bits are used to denote the network ID. So you can count, starting from this one, you can count out where does the 27 ends here. Here, it ends here. This up to this one is 24, 25, 26, 27. It ends here. So if I want to find the first IP addresses, the first IP address is the network ID itself. So the remaining 5 bits will be converted into zeros here. Since up to this one is your network ID, so the remaining bit will be converted into zeros. When we convert into zeros, then this all together, this 8 bits, it is now becomes 64. Previously it was 82, now it becomes 64 here. So we'll convert all of them back to the binary notations here. Now it becomes 167, it remains the same, 199, 170.64. /27 is for the CIDR notations here. So this is your first addresses. Similarly, we have to find out the last addresses. Similarly, we have converted into the binary format. We have count up to the 27 number of bits up to this one, and the remaining 5 bits. Now here, we must not convert into zeros. We are finding the last IP addresses. The last IP will be, we have converted them into all ones here. Now these 8 bits together, it denotes the 95 in decimal notations. So we have written this one in the decimal notations, /27 for the CIDR notations here. So that is how we actually find the IP addresses. The first IP addresses, the last IP addresses here, and also the number of addresses in the network in this given questions here. That is for the CIDR notations here. So this CIDR notations, it becomes easy to use other than your classful IP addresses. In classful IP addresses, we have class A, class B, class C, class D, and class E. In class A, we denote IP addresses. You know how to identify whether it is a class A, class B, class C, and a class D, or class C addresses. D and E are not used here. We have used up to the class C addresses. So we have so many applications using this CIDR notations here. One of the questions I want to ask is, Suppose if I want to form an organization having only 250 computers, in their organizations we have only 250 computers, then which type of IP address you will use so that you have the maximum efficiency? Means there is less loss of resources, means the number of IP addresses left out or unused should be minimum, whether you will be using the classful addresses or the classless inter-domain routing. Okay, so this is up to the CIDR notation part. So next time we'll come out with the next topic regarding the computer network. Thank you.